taking as part of the class that I'm taking for summer semester. So the objective of this program is to read a dataset called train CSV. From that, fetch data from the two columns called garage area and sales price, and basically you need to plot all the values in a scatter plot and filter the anomalies from those data. So if you see here, the train is basically reading a CSV file called train CSV, and from that we are finding the garage area and sales price, and using the scatter plot and plotting the both garage area and trains sales price, and from that I'm making a filter on of certain data and then again showing them on a scatter plot. So let's run this code and see what happens. So as I'm printing both the garage area and sales price, what are those values in the data looks like? So basically, so there is 1460 rows in the data set. So you see the garage area of each row as well as the sales price of each row, and then basically I'm plotting the entire area with garage area as on x-axis and sales price on y-axis. So if you see, all the values before 200 on garage area and after 1000 are basically anomalies, and of the sales price 50,000 are anomalies. So in order to filter the anomalies, I use the values saying that okay, garage area has to be between 200 and 1000 and sales price has to be less than 50,000. So now my data looks like this. So you see now the data is like well clustered. Okay, this is one part of it. The second one was to read the data from a CS dataset called Y inequality. So basically here we are doing a multiple regression. So one of the objective was to find out the top correlated features. So basically I'm finding the correlation of all numeric features and sorting them using the descending order, so I'm finding the top 3 of them. And then the other objective was to remove null values from data. So basically from this I'm finding the feature and how many null values across that, and any missing values I'm handling that by saying drop NA, so that any null values will be dropped. And the other objective was to find the R square and RMSE data, root mean square error from the data. So this is the data, as quality is my target variable. So I'm splitting my data set into x, y of both test and train, and fitting a linear regression line on my x and y data as well of training and as well as test data. So I'm running the data file. So basically these are the top correlated features, and these are all the values, null values present in each column. Yeah, and this is the R square after running the linear regression on top of it, and this is the root mean square error of it. Thank you.